I want you to try a thought experiment right now. Just, I want you to imagine that the universe you're sitting in, like the chair beneath you, the air in the room, even the device you're listening to this on, isn't actually made of atoms.
Right.
It's not made of, vibrating strings or quantum energy fields either. I want you to imagine that the universe is fundamentally made of pure, rigid numbers. And I don't mean numbers as like a metaphor or as a tool we invented to measure physical things. I mean numbers as the literal, foundational, physical truth of reality.
Yeah, it is a completely paradigm-shifting way to look at existence. And honestly, it can be, well, it can be a little unsettling when you first start looking at the evidence because it strips away literally everything we intuitively feel about the physical world.
Unsettling is exactly the word. So, for this deep dive, we are opening up a really fascinating stack of sources. Primarily, we're looking at this incredibly dense, cutting-edge paper titled Arithmetic Architectures and the Cosmic Continuum.
Which is a mouthful.
It really is.
Yeah.
And we're pairing that with a series of recent theoretical physics frameworks that were published between 2024 and 2026. So our mission today is to really explore this wild premise. Are the things that look like, random cosmic coincidences actually the necessary, unavoidable results of a highly symmetrical mathematical architecture?
Exactly.
And you're going to want to hear this because by the end of this deep dive, you might look at the physical world around you, I mean, even your own biology, as just a byproduct of pure arithmetic.
Yeah, and to really grasp how modern physicists arrived at this idea, we have to trace the breadcrumbs back to the late 19th century.
Right, to George Cantor.
Exactly, starting with a mathematician named George Cantor. He completely revolutionized mathematics by doing something that was considered almost heretical at the time.
Yeah, which unfortunately ended with him in an asylum in Halley, right?
Yeah, really tragic end. But before that, he treated infinity not as some, vague, endless philosophical concept, but as a precise, measurable mathematical object.
Right, the idea that infinity isn't just, like, everything forever, but a structure you can actually categorize.
Precisely. I mean, Cantor proved there are actually different sizes of infinity.
Which sounds impossible.
Right. But, for example, the infinity of countable whole numbers, like 1, 2, 3, on forever, is actually a smaller infinity than the uncountable, continuous real numbers, which includes literally every possible decimal between those whole numbers.
Wow. Okay.
So he mapped out this hierarchy of the infinite. And while he was doing that, he accidentally set the stage for a massive crisis in mathematics, a crisis that would eventually force us to completely rethink the fabric of reality.
Wait, I can see how different sizes of infinity might, break a philosopher's brain. But how did it lead to a crisis in basic math?
It had to do with the fundamental building blocks of numbers themselves, something called unique prime factorization. Let's think about normal whole numbers. Every number has one, and only one, unique set of prime factors. Think of it like a molecular fingerprint. The number 6 is always composed of 2 times 3. Both 2 and 3 are prime. That unique fingerprint is the absolute bedrock of arithmetic. But when mathematicians, inspired by people like Cantor pushing the boundaries, started expanding into more complex multidimensional number systems.
It's throwing the square roots of negative numbers into the mix.
Exactly. When they did that, that fundamental rule just shattered.
Let me make sure I'm visualizing this correctly. So if we imagine a standard number like 6 as, say, a box of 6 physical blocks, normally there is only one way to break that box down into its prime components, which is 2 groups of 3. You're saying that by adding these imaginary numbers into the math, that basic rule just stopped working. Like, how is that even possible without math completely falling apart?
It almost did fall apart. I mean, in that expanded system, the number 6 can suddenly be factored into completely different ways. You can still do the standard 2 times 3, but the math also allows you to factor it as 1 plus the square root of -5 multiplied by 1 minus the square root of -5.
Oh, wow.
Yeah, and all 4 of those components are irreducible. They're all essentially prime in that system. So suddenly, the bedrock of mathematics, the idea that every number is uniquely constructed from a single set of primes, was fracturing.
That sounds like finding out the foundation of your house is actually made of quicksand. If the basic rules of multiplication break down when things get complex, how did anyone trust math again?
Well, a mathematician named Richard Dedekind stepped in with this brilliant patch called ideals.
Ideals.
Yeah, he created a new set of rules to group numbers together so that the fingerprint of a number could be preserved even in these weird expanded dimensions. And the key metric of Dedekind's system was something called a class number.
Okay, I'm following.
When a number system has a class number of exactly 1, the unique factorization works perfectly again. The quicksand turns back into concrete.
Thank God.
Right, but here is the massive catch that changes everything.
Right.
There are only 9 negative numbers, known as Heegner numbers, that actually achieve this perfect class number of 1, and the absolute largest of these 9 numbers is 163.
Okay, here's where it gets really interesting.
Yeah.
Because 163 is the ultimate capstone number, right?
Yes.
It's the highest mathematical anchor that keeps the rules of arithmetic from breaking when systems get infinitely complex. And it's when we look at how 163 behaves in geometry that things get crazy.
Oh, it gets wild.
Yeah, if you plug the number 163 into a specific equation for complex elliptic curves, which visually these look like higher dimensional donuts or toruses,
Right.
something almost magical happens. You get an equation featuring e to the power of pi times the square root of 163. And the result of that equation is roughly 262 quadrillion, followed by 12 nines and ending in a 25.
Yeah, and what's fascinating here is that to the untrained eye, that looks like just a wild coincidence. I mean, it's a massive complex equation that involves irrational numbers like pi and e, and it just happens to land a microscopic fraction of a hair away from a perfectly round, massive whole number.
Right, like 9999999999925.
Exactly. Mathematicians call it a fast integer, but the sources make it clear this isn't a coincidence at all. It is a mechanical necessity.
Oh.
Because 163 has a class number of 1, it has no other factors to muddy the waters. It forces a kind of intense geometric rigidity. The math literally has no choice but to balance out perfectly to maintain its symmetry.
So it's like building a skyscraper.
Okay, yeah.
Like the Heegner numbers are the primary load-bearing pillars. If they aren't perfectly placed, the geometry of the whole building collapses under its own weight. And 163 is the absolute biggest pillar holding up this mathematical donut.
That is a great way to put it. And to push that skyscraper analogy further, if 163 is the central load-bearing pillar, the incredibly precise outcome of that equation is just the natural result of the building standing up straight. It is structural necessity masking itself as a numerical fluke.
Man. Which brings us to the human mind that actually spotted this fluke. Because the sheer precision of that equation we just talked about, that calculation is known as Ramanujan's constant.
Named after Srinivasa Ramanujan.
Yes, exactly. Now, for you listening, Ramanujan is a really central figure in this deep dive. He was an early 20th century mathematician who had this uncanny, almost supernatural intuition for these exact types of numbers. He didn't just solve equations, he seemingly pulled them out of the ether.
He really did. Ramanujan possessed a mind that seemed to bypass standard step-by-step logic to just see the underlying mathematical truths of the universe.
Right.
And to understand how deep this goes, we have to look at his work on the partition function, which is denoted mathematically as P of n. This function simply calculates the number of ways you can add up positive integers to get a specific number.
So if I take the number 4, there are 5 ways to partition it. You can do 1 plus 1 plus 1 plus 1, or 2 plus 1 plus 1, 2 plus 2, 3 plus 1, or just 4.
Right. It starts off deceptively simple, but as the target number grows, the combinations absolutely explode. By the time you get to the partition function of 200, there are nearly 4 trillion different combinations.
4 trillion for just the number 200.
Yes. Trying to count that by brute force is impossible. But Ramanujan, working with the British mathematician G.H. Hardy, didn't just try to count them. He figured out the underlying rhythm of how that growth happens. He found a way to calculate the asymptotic growth, essentially predicting the curve of this explosion using incredibly complex spatial mathematics.
And his intuition didn't just stop at counting numbers, right?
Yeah.
Because he pushed into territory that was decades ahead of his time, which leads us to this legendary deathbed letter.
Yeah, this is where it gets kind of spooky. In 1920, right before his tragic early death, Ramanujan wrote a final letter to Hardy. In it, he describes something he called Mach theta functions.
Okay.
To put it simply, these are mathematical functions that behave beautifully and predictably, following smooth curves, what mathematicians call modular forms. But at their boundaries, at the absolute edge of their mathematical domain, they start behaving unpredictably. They exhibit chaotic, asymmetric behavior.
Interesting.
Yeah, and Ramanujan mapped out the exact rules for how these functions break down at the edge purely through intuition.
And the sources we have from 2024 to 2026 drop an absolute bombshell about this. Those exact Mach theta functions, which Ramanujan dreamed up in 1920, are now being used in modern string theory to calculate the microscopic states of black holes.
It's unbelievable.
Let me admit some serious confusion here, though.
Wait,
How could a guy in 1920, working purely with numbers, map out the physics of black holes before we even knew what black holes were? Like, how does a pure math equation about the edge of a number graph map onto a collapsed star?
because the mathematics of a Mach theta function perfectly mirrors the physics of an event horizon.
Oh, wow.
Right, think about a black hole. Inside a normal area of space, physics works predictably. But at the event horizon, the boundary of the black hole gravity becomes so intense that the standard rules of space and time break down and swap roles. The mathematical boundary of Ramanujan's function behaves exactly like the physical boundary of spacetime.
That's insane.
The chaotic behavior at the edge of his math perfectly calculates the entropy, which is the exact number of microscopic quantum arrangements at a black hole surface. He was able to do this because he had an unparalleled ability to see the dominant terms of the universe's structure without needing modern analytical tools.
So he just saw the code.
Exactly. And recent work by theoretical researcher Michele Nardelli takes this even further. Nardelli has shown that the coefficients, like the specific numerical multipliers inside Ramanujan's Mach theta functions, actually act as energy eigenvalues.
Meaning what, exactly?
In simpler terms, these numbers dictate the exact discrete energy levels allowed in the fabric of discrete spacetime itself. Nardelli effectively proved that Ramanujan's math is the DNA of gravity.
The DNA of gravity. Wow.
Yeah.
So if the number 163 in Ramanujan's functions give gravity its shape and structure, what happens when we look at the physical limits of the matter actually sitting inside that shape?
Right.
That brings us to two other hard boundaries in our stack of sources, the numbers 65537 and 137.
Let's start with 65537, which beautifully illustrates the limit of pure geometry. This is a very special type of prime number called a Fermat prime. It's f sub 4.
Okay.
In theoretical mathematics, it's proven that you can draw a perfectly regular polygon with exactly 65,537 sides using nothing but a simple compass and a straight edge.
And the reason you can mathematically do that is because the arithmetic behind that specific number breaks down perfectly into exactly 16 consecutive square roots. It is logically flawless.
On paper, yes.
But physically doing it. There's this unbelievable anecdote in the source about a German mathematician named Johann Gustav Hermes. He spent 10 entire years of his life, back in the late 1800s, meticulously writing out a massive manuscript to detail the exact step-by-step construction of this 65537-sided polygon. 10 years.
This is just a monumental feat of human dedication, but ultimately a purely theoretical one.
Exactly.
Yeah.
Because as the source points out, drawing it physically is literally impossible in our universe. If you tried to draw a circle large enough to fit 65,537 distinct straight sides, the physical width of your pencil lead or, even a single microscopic atom of graphite would blur the lines together long before you finished.
Yeah.
You cannot physically distinguish the sides. It completely proves that the logical arithmetic structure of the universe is actually superior to and infinitely more precise than physical reality itself. Physical matter is just too clunky to handle the pure math.
Which is the perfect bridge to our next number, 137. Because if 65537 shows us that physical matter is too clunky for perfect geometry, 137 dictates exactly how clunky that matter is allowed to be.
Real limit of physics.
Exactly. Specifically, the fraction 1 over 137.036 is known as the fine structure constant. This single number dictates the exact strength of the electromagnetic force in our universe. It determines how light photons interacts with matter electrons.
And if this number were even infinitesimally different, the universe as we know it simply wouldn't exist, right? If the electromagnetic force were slightly weaker, atoms wouldn't hold together. If it was slightly stronger, atoms would violently snap together.
Right. And to understand why it's a hard physical limit, we have to look at the periodic table. As you add more protons to the nucleus of an atom, the electromagnetic pole gets stronger. To keep from crashing into the nucleus, the inner electrons have to orbit faster and faster.
Makes sense.
So if you follow the math of 137, there is a hypothetical element right at the edge of physical possibility called untriceptium, which would be element 137.
And according to the Bohr model of the atom, for untriceptium to exist without instantly collapsing, that massive positively charged nucleus would require its innermost electrons to literally travel at the speed of light just to stay in orbit.
Exactly.
And since matter with mass cannot travel at the speed of light, the atom breaks. It's a hard physical wall. You simply cannot cross it.
It is the ultimate speed limit encoded into the elements themselves. And the pursuit of understanding why that number is exactly 137 became an absolute obsession for many physicists and mathematicians.
Like Sir Michael Atiyah.
Yes, Sir Michael Atiyah, one of the greatest mathematical minds of the 20th century, spent his controversial final years trying to mathematically derive 137 from pure logic. He tried to do this using something called the Todd function and tying it directly to the Riemann hypothesis.
Right, which caused quite a stir.
It did. His final proofs were met with massive skepticism. Many in the academic community found his definitions too vague to hold up. But his underlying intuition remains a driving force in modern physics today. The idea that the distribution of prime numbers and the universal physical forces holding our atoms together spring from the exact same mathematical well.
Okay, let's unpack this connection between prime numbers and quantum physics, because the Riemann hypothesis isn't just like an abstract math puzzle about how prime numbers are spaced out. It actually seems to be the rhythm track for physical reality.
It genuinely does. Back in the 1970s, physicists who were studying quantum chaos stumbled onto something terrifyingly beautiful. They were looking at the statistical spacing of the zeros in the Riemann zeta function, which, simply put, is the master equation that governs how prime numbers are distributed along a number line.
Right.
And they realized that the complex spacing of these mathematically generated zeros exactly matched the energy absorption levels of heavy atomic nuclei.
That's crazy.
The universe literally plays the rhythm of the primes. It's built into the vibration of the atoms themselves.
And that prime number rhythm brings us to the absolute cutting edge of our sources today. The newest theoretical frameworks published between 2024 and 2026, the Nardelli Master Equation, or NME, and the Nardelli-Miriam Unified Equation, the NMUE.
Yeah, these frameworks take literally everything we've discussed so far. The structural necessity of the Heegner numbers, the black hole mappings of Ramanujan's functions, the hard physical limits of the fine structure constant, and they synthesize them into one cohesive model.
Putting all the pieces together.
Exactly. They propose a radical idea. The universe is not random. It is not a chaotic accident of particle collisions just trying to find equilibrium. Instead, it is actively running what they call a predefined harmony algorithm.
Wait, a harmony algorithm?
Yeah. The source details how this algorithm is constantly seeking the lowest possible energy state by aligning with these mathematical frequencies. And it uses a modified golden constant, specifically the number 1.618665, to smooth out the infinite mathematical errors or vacuum divergences that pop up in relativity.
Wow.
And to hold all this together, the framework introduces something called the Synchronia 1729.
Ah, 1729. That is a famous nod to Ramanujan's legendary taxicab number.
Yes. In this new multidimensional physics framework, the Synchronia 1729 acts as a mathematical attractor. Think of it as a gravitational anchor. It stabilizes our observable universe, which physicists call our 4D brain world, within a massively complex 26-dimensional string manifold.
26 dimensions.
Yeah, that 26-dimensional space is essentially the mathematical arena where all these equations are allowed to exist without contradicting themselves.
But having 26 dimensions interacting with our four-dimensional reality creates a massive amount of friction.
Right, absolutely.
So to keep this entire complex structure from vibrating itself to pieces, the framework relies on something the papers call quantum lubrication,
Right.
which is a flow of bosonic particles carrying exactly 14 megaelectron volts of energy. So it's basically like the suspension system in a car. Without that exact 14 MeV of energy acting as quantum shock absorbers, the violent vibration of those 22 hidden higher dimensions would shake our three-dimensional universe apart.
That is exactly how it functions. The quantum lubrication absorbs the dimensional friction. The universe is computing its own existence, using prime numbers and modular forms as its base code, and generating just enough energy to keep the hardware from shaking itself apart.
So instead of the universe being a random explosion of particles, the NMUE suggests it's more like a self-regulating holographic operating system. And this quantum lubrication is the cooling fan keeping the space-time server from crashing.
That's an amazing analogy, yes.
Okay, so what does this all mean for you, the listener, right now? I mean, we've been talking about 26 dimensions, shock-absorbing particles, and complex mathematical donuts. It sounds incredibly abstract, almost like science fiction. But the sources make it explicitly clear that mapping this arithmetic architecture has massive, tangible, real-world applications happening today.
Absolutely. It's not just theory. The very math Ramanujan pulled from his intuition a century ago is currently driving modern material science. For instance, his partition theory, the math describing how numbers explode into different combinations, is being used right now to model complex polymer chains.
Oh, right, like plastics.
Exactly. It helps engineers predict how molecules will fold, allowing us to design better, more resilient plastics and synthetic materials.
And it is heavily integrated into the digital device in your pocket, too. That massive Fermat Prime 65537. Because of its unique geometric rigidity, it is actively used as the standard public exponent in RSA encryption. Every time you buy something securely online or send an encrypted message, the geometric limits of that exact number are mathematically protecting your data.
Yep.
And Ramanujan's elliptic curves. They are the absolute foundation of post-quantum cryptography. They are the security systems being built today to keep your digital life safe from the code-breaking supercomputers of tomorrow.
It even reaches into life-saving medicine. Researchers in oncology are currently using Ramanujan's Mach theta functions to model the behavior of solitons, which are these solitary, self-reinforcing wave packets inside malignant cancer cells.
But really? Using math for cancer research?
Yes. By mapping these boundary functions, they're literally trying to understand the fundamental mathematical rhythm of cancer proliferation so they can disrupt it.
That is incredible. Which brings us to a really beautiful concept in the papers. Information as an essence.
Yes, the concept of emergence. This is a core underlying principle in all of these new physics models. Emergence is how complex, highly sophisticated properties arise from extremely simple, rigid parts.
Like how water is wet.
Right. Water feels wet to us, even though a single isolated oxygen or hydrogen atom has absolutely no concept of wetness. In this new framework of digital physics, mathematical information isn't just passive data written in a textbook. Information is a fundamental active essence of the universe. It's a physical property that dictates how reality emerges from the numbers. It crosses space-time bridges.
And the most incredible part is that we are no longer mapping this architecture alone.
Yeah.
The sources highlight that modern AI systems, specifically a highly advanced neural network named Miriam Maria Celeste, are now working alongside human physicists.
Which is game-changing.
Yeah, these AI systems act like a synthetic Ramanujan. They can process billions of data points simultaneously, spotting hyperdimensional arithmetic patterns in the quantum static that human minds could never visualize.
They are helping us read the foundational code of reality faster than we ever thought possible. They're acting as a bridge between human intuition and the raw computation of the universe.
Which leaves us with the ultimate question. Looking at the sheer absurdity of these connections, the fact that the number 163 perfectly aligns the geometry of complex space, that 137 acts as a hard speed limit for physical matter, that a man in 1920 dreamed up the exact boundary math needed for 21st century black hole physics.
It's a lot to take in.
It really is. We have to ask, is this high-level trolling by nature? Are we just finding patterns in the clouds, or is this intentional design?
Well, if we connect this to the bigger picture, the answer becomes incredibly profound. Mathematics isn't an invention. We aren't creating these numbers or writing these rules to conveniently fit our observations. It is a pure discovery.
We're just finding it.
Exactly. We are explorers uncovering a rigid, pre-existing structure. We aren't looking at random cosmic chaos that we just happen to be describing well. We are literally reading the source code of the universe.
Man. Well, thank you so much for joining us on this deep dive. And I want to leave you, the listener, with one final thought, building on this idea of the universe as a rigid mathematical code. If the physical universe is just a holographic projection of these rigid, perfect numbers, and if Nardelli's equation suggests that consciousness is an intrinsic property of this cosmic architecture, then your mind, the very thing you are using to understand these numbers right now, isn't just observing the math. Your consciousness might literally be a localized, self-aware piece of the equation trying to solve itself. Think about that the next time you look in the mirror.